Okay, in this demonstration we're going to look at how to use R Commander to do simple transformations of data. Okay, I've got a specific data set for this which I've created. So I'm going to import that data from text file, comma separated values. Okay, and the data set I'm going to use is actually called transformations. It's just a dummy data set set up to demonstrate this for you. If we view that data, you'll see there are four variables in there. One's called Poisson1, one's called binomial, one's called x, and one's called y. Okay, so we're going to look at Poisson1. It's actually Poisson data. There's 100 observations, and we're going to look at creating a square root transformation of that data. Okay, we do that through the Data tab in R Commander. We go to the bottom entry there, Manage Variables in Active Data Set. And the thing that we want is compute new variable, which is the second entry there. We'll click on that. Okay, we see a list of the variables and it says double click to put it in the expression, and this is the expression box here. So we're going to double click Poisson and that puts it in there. Okay, we're going to then go to the start of that and say square root, SQRT, open brackets, and at the end we put close brackets. So that means that's the expression that will be calculated to compute the new variable. Now let's give the new variable a sensible name. Let's call it square root Poisson. Okay, we just do that. We click OK. And now if we review the data set, we'll see there's actually an extra variable in there called square root Poisson. Now just out of interest, we could do some graphs maybe. Let's do a box plot. Let's do a box plot of Poisson. Okay, and that's what we see. And if we went back and did a box plot of square root Poisson, that's what we'd see there. Looks a little bit more symmetrical, and that's how it should be. It should be more normally distributed in a sense. Okay, so let's look at now how we might do the binomial, deal with the binomial variable. One way to deal with that is to go into Manage Variables, Compute New Variable, and let's this time think about an arcsine transformation. So first of all, we'll delete the old expression. We'll delete the old variable name and we'll call it arcsine, and I'll do that as RA-sine for short, and I'll do bin for binomial. Okay, I'll double click binomial, that puts it over here in the expression to compute. I've actually got to do two things now. I've got to use a sine, that's an R function that calculates an arcsine, but I also have to do the square root. Okay, and it's not of the actual binomial, it's of the proportion, and I happen to know these binomials are out of 5. So I divide by 5 to create that as a proportion. Okay, and I have to close two lots of brackets to do that. I click OK. And that's computed now, so I can close that and reopen the data set, a variable called a-sine binomial. Okay. If the binomials were out of different numbers, we'd have to compute that more carefully. We'd need a variable in the data set that does that. Okay, so finally I want to look at log transformations. Now these x and y variables are variables that we can do a linear regression on. So let's just do that. We'll go to Fit Models, Linear Regression. The response is going to be y. The explanatory variable is going to be x. I'll click OK. We can see the information down the bottom here. I'm not really interested in that. Let's look at the residual plot. So I go to Models, Graphs, Basic Diagnostic Plots, and the plot's gone down off the screen. Let me bring that back up. Okay. If we look at the residuals versus the fitted values, we can see that the residuals seem to be smaller as we go from left to right. It's kind of funneling in effect, and this is what we see when the variance is non-constant. We either see it funneling in or funneling out. Okay, so what can we do about this? Okay, well, one of the things that we can try is to take a log transform of the y variable. Okay, so we go back here to the Data tab, Manage Variables and Dataset, Compute New Variable. Okay, I'm going to be interested in the y variable. I need to first of all delete the stuff I had before. Okay, so let's call the new variable log y, log e. double click y, it puts it in there. I can type log of y. Now in R, as in most mathematical packages, log is actually the natural log, which you might know as ln. But in R, log is a natural log. We can do log to the base 10 if we like by replacing log by log 10. For this example, it doesn't really matter. It makes no real difference because it only really changes the value that you get by a scale factor. Okay, so we'll use log base 10 since that's what I've typed now. Okay, so click OK. Now we need to go back and build the model. So we're going to go back to fit models linear regression. Okay, our response variable now, we've got to scroll down a bit to find it. There it is, log y. Our explanatory variable is the same x. Click OK. We get the same sort of output here. Alright, so this time the p-values are hardly significant, which they weren't before if you didn't notice. But what we're really interested in are the graphs, so we go to models, graphs, basic diagnostic plots. If we now look at them, we can see not only is the residuals much more evenly spread, the red line shows a little bit of curvature. I guess I'm not too worried about that in this particular case. But the normal probability plot actually looks better as well. Okay, so that's an example of the use of a log transformation to try and improve or improve the compliance with the assumptions for simple linear regression. Okay, and that's the end of this video.